All right, welcome to lesson 4 for chapter 15. This is a longer lesson. I apologize for that, but we will make it through. So chapter 15 has been all about water. Lesson 4 is specifically about water pollution. So there's a lot of different ways that we as humans pollute the water, which is why this is a slightly longer lesson. Learning goal here is that you should be able to describe the different sources of water pollution. So, a few success criteria. By the end of this lesson, you should be able to list the major sources of water pollution, define biochemical oxygen demand, aka BOD, differentiate between point and non-point sources of pollution, so you should be able to tell the difference between those two, and then explain how heat can be a form of pollution. We'll talk about like actual physical pollutants like chemicals and particulates and all of that, but heat is also one. Okay, so right off the bat, let's talk about organic matter. So dissolved organic matter is a significant water pollution problem because it decays in the water. So dissolved organic matter, that's like things breaking down. It's organic matter is coming from living things, and it decays. So biochemical oxygen demand, remember this is one of our success criteria, is the amount of oxygen required to decay a certain amount of organic matter. So decomposers that are breaking down things that are dead, dying, whatever, rotting, they have to use oxygen, and so BOD, biochemical oxygen demand, is the amount of oxygen needed to break down a certain amount of organic matter. If too much organic matter is added, then it will use all of the oxygen, because remember, we're talking about water. There is oxygen in water, but there's only so much available. It's not, all surrounding. So if we run out of oxygen, then the only thing left to break things down is going to be anaerobic bacteria, because anaerobic means no oxygen, so anaerobic bacteria begins to break down that waste, and when that's the bacteria doing it, it gets really nasty and smells gross. So the other concern that we have with sources of water is disease-causing organisms that are very important pollution problems in most of the world. So it's not as much of a problem here in the US, although it is. It's a much bigger problem elsewhere where there's not as much filtration happening. So untreated or inadequately treated human or domesticated animal waste is most often the source of these organisms. So it's coming from waste, which we don't want to consume because it makes us sick. So in the developed world, sewage treatment and drinking water treatment plants greatly reduce this public health problem. Remember, it does not fully remove, but it does make it a little less. Okay. So nutrients can also be a pollution problem. Pollutants are kind of like weeds. It's like people say weeds are plants you don't want growing there. Pollutants are things you don't want where they are, or it's too much of a thing. So it can be good things. Nutrients typically we think of as good things. Too much, not so good. It can lead to eutrophication, which is what we kind of see happening in this lake over here. So eutrophication is the excessive growth of algae or aquatic plants due to added nutrients. We talked about this previously last semester, but you add more nutrients to the water, the plants are going to grow a lot more. And as more plants grow, those plants and algae are going to die, which then increases the amount of decaying happening, which means, remember, BOD, biochemical oxygen demand. As more things are dead and dying, we have to use more oxygen to break them down, and then we run out of oxygen and we have no fish. And it's sad. And also makes the water really, really gross. So particulate matter can also affect quality. So like sand, silt, soil, clay ending up in the water. Particulates can alter the clarity of the water, which some organisms need clear water to, live their lives. They can also cover spawning sites, and it can act as abrasives that injure organisms. A lot of aquatic species are pretty hardy, but a lot of them can be really delicate, especially if you think about fish breathing through their gills. Any particulates ending up there, not so great. Particulates can also carry toxic materials that can then, harm the living things. Okay, so remember one of our success criteria is point source versus non-point source. Here's where we're covering that. So a point source is a source of pollution readily located and identified. You can point to it. Right there, I can see there is a pipe that is dumping stuff into this thing of water. This looks like a water treatment facility, so like fair. But the point is we have this body of water, nasty stuff's going into it, and I can point exactly to where that's happening. So examples are municipal and industrial waste discharge pipes. Non-point sources are more difficult to identify and control. You can maybe say it's coming from this area, but you don't know exactly the single spot it's coming from. So diffuse pollutants from agricultural land and urban paved spaces come from non-point sources. This means the nutrients that are coming from agricultural sites or the animal waste coming from agricultural sites. Yes, we could say that farm is polluting right there. It's coming from that space, but we can't point to one location and say this is where it's coming from. And then for urban paved surfaces, when we're driving on roads or parked in parking lots, there's oil and other chemicals coming out of the cars. When it rains, those chemicals then wash into the water system. That's a diffuse pollutant. It's coming with the runoff of the water on the surface. That's a non-point source. And then acid rain is another one. Okay, so let's look at what we have more effect over. So individuals can protect surface and groundwaters from non-point pollution by using less toxic or non-toxic alternatives to commonly used home chemicals, buying chemicals only in the amount you intend to use, and applying them only as directed. More is not always better. More can be dangerous for you and the environment. Take unwanted household chemicals to hazardous waste collection centers. Do not pour them down the drain or just dump them in the trash, because if you dump them in the trash, that's still going into the rainwater, or rainwater is going to wash it into the water sources. So municipal water pollution. Waste from homes consists primarily of organic matter from garbage, food preparation, cleaning of clothes and dishes, and human waste. Fecal coliform bacteria is a generic term for bacteria found in the intestines, such as E. coli and Streptococcus faecalis. Great. Those make us very sick. Numbers and types of bacteria present in water are directly related to the amount of fecal matter entering the system. The more poop, the dirtier the water. Like that's just how that's going to happen, which means the more energy we need to put into cleaning it, hopefully. By January 2011, over 2,000 Haitians died from a cholera outbreak due to contaminated drinking water. So for places that maybe don't have the technology or ability that more developed countries do to clean water, they don't have the luxury of saying, we'll just clean our water. You have to drink, so they have to drink the water that they have. So wastewater from cleaning dishes and clothing contains some organic material along with soap or detergent. And at one time, many detergents contained phosphates, which contributed to eutrophication. These have since been eliminated since 1994. Pharmaceuticals, hormones, detergent, metabolites, insecticides, fire retardants, plasticizers, among other chemicals, can also be found in municipal waste discharge. So what was being released from our houses. And you may think that's fine, it's staying in the pipes, right? Like it's a closed system. I'm creating wastewater, but then it's going to the treatment site and then it's coming back. Fine. Not fine. In a study of 139 streams through the U.S. Geologic Survey, or USGS, found one or more chemicals in 80% of the sampled streams. So even like water in the wild is affected. These chemicals largely escaped regulation and are not removed by municipal wastewater treatment. So even saying it's fine, it's going to treatment, treatment does not remove everything. We haven't gotten there yet. Agricultural activities are the primary cause of water pollution. So if we're looking at what's causing the most issues, growing our food. Excessive fertilizer can lead to eutrophication in many aquatic habitats. Remember, eutrophication is coming from excess nutrients. Runoff from animal feedlots carries nutrients, organic matter, and bacteria. And agricultural runoff from large open expanses is a major source of water pollution, but it can be controlled. We can leave a conservation buffer, we can keep soil covered with crop, and we can also control the amount and timing of fertilizer application. For industrial water pollution, so like when we're mining, factories and industrial complexes frequently dispose of waste in municipal sewage systems, but these wastes require special wastewater treatment, and mining is a special source of industrial water pollution. Chemical runoff can then be released into streams of chemicals that are released through the industrial or mining processes, and the water draining from mines is super acidic, which not every creature can survive. For thermal pollution, that occurs when industry withdraws water from a source, uses it for cooling purposes, and then returns heated water to its original source. So, one of our success criteria is how can heat be a water pollutant? This is how. So its release could be steam from steam turbines that's condensed in the water after leaving turbine for maximum efficiency. That's how we could decrease how much we're releasing. But an increase in temperature, even just a few degrees, can significantly alter aquatic ecosystems. Today in the industrialized world, most cooling water is not released in such a way that aquatic ecosystems are endangered. We have made changes, but it still is a problem in some spaces. So other methods of getting rid of heated water could be large shallow cooling ponds that are more contained to that industrial location. Heat then dissipates from the pond. We could have cooling towers, or we could have dry towers. For marine oil pollution, I think this is one we see a lot because it's in the news, such as the Deepwater Horizon spill in 2010. And then also in 1989, the Exxon Valdez ran aground in Alaska and spilled 11 million gallons of oil. And this affected almost 1,000 miles of coastline. And the economic impact was huge because if your money's coming from oil, you just lost a ton of it. And if your money's coming from tourism, you're now covered in oil and you're going to lose money there. And this was the Deepwater Horizon spill of 2010. So the U.S. National Oceanic and Atmospheric Administration determined that 50% of the water spilled biodegraded on beaches or in the water, 20% evaporated, 14% was recovered, 12% is on the sea bottom, 3% is on the shorelines, and 1% is still drifting out somewhere. So because tanker accidents are spectacular, we see them a lot in the news, but tanker accidents are not where we see most of the oil being released into the water. More oil is released as a result of small regular releases from other sources, such as street runoff, just us driving our cars, oil leaking onto the streets, and then it raining and taking that to the water. Improper disposal of lubricating oil, so like oil changes for your car, or intentional oil discharge during tanker loading and unloading. An international agreement was reached in 1992 that declared that all new oil tankers had to be double-hulled to protect them a little more from leaks. Most tankers today are double-hulled, and only double-hulled tankers are allowed in United States waters. All right, so the last big thing we're going to talk about is groundwater pollution. So major sources of groundwater pollution include agricultural products. Again, agriculture is going to be the #1 pollutant of our waters, like pesticides. Underground storage tanks that can leak. Landfills. Think about all that trash sitting there, the chemicals you throw away, the nastiness you throw away. Water, when it rains, that's going to sink into the groundwater. 96% of landfills don't have systems to collect what leaches out. Could also come from septic tanks, that's human waste, surface impoundments, and then this is an example of what we could see. So a landfill leaking, gas stations, roads, waste, oil wells, coal mining, accidental spills, de-icing salts, those are going to end up in the water, pesticides. There's a lot of different things. So with that in mind, your next practice is going to be a groundwater pollution worksheet. So a little less complicated than this guy, but your worksheet's going to have this picture on the front. There's a damaged septic tank here, industrial waste, 2 different wells, and you're going to answer a few questions on the back. If you have any questions, please let me know, and I will see you in the next one. If you're still here, these are the possible questions that could be on your exit ticket in the coming days. So take a look at these, see if you can answer them. If you can't, maybe rewatch or ask me.